In this question, it says the sequence of operations for riveting is shown below in the correct order. However, the diagram accompanying the sequence of operations are shown in the incorrect order. Write the correct number of the sequence of operations in the box next to the diagram. The first one is done for you. So we can see that for cutting the rivet to the correct length, that this is the diagram for that is the second one from the bottom, where it actually gives you one as the correct operation. The next one, bring pieces of metal together with the rivet set. Well, that would be the very bottom diagram. Swell the rivet with the flat face of the hammer. That's going to be the second one from the top, down from the top. You can see the flat head of the hammer, and what that's going to do is just going to, upset the end of the shaft of the rivet to make it wider. Form the rivet head with a ball peen hammer, and that's going to be the very top diagram. You can see that the round head of the ball peen hammer hitting at an angle to begin to create the round head, and then finish forming the head with the snap. So that's the third one down, where we use both a snap underneath and a snap on top to finally form a nice round shaped head to the rivet. Explain one advantage of countersinking the rivet instead of forming a dome. Well, it might be the case that you're maybe wanting it to be flat on one side. So instead of using a rivet that's got a round head on both sides, you could countersink the other side of the hole and rivet it so that it's flat on that side. The tool shown below was used during the manufacture of the door latch. Name this tool. Well, this is a digital micrometer. Two readings from the tool are shown below. State the correct readings shown above. If we look at this one here, reading A, you can see that it's on the left-hand side scale, it's somewhere between 5 and 0.5 and 5.5. And then the vertical scale here, if we look at that, it lines up to the left-hand scale at 20, so that's 20 hundredths. So 5 millimetres plus 20 hundredths is 5.2 millimetres. If we look at this one, if we look at the left-hand side, we can see that it's above 2.5 millimetres. And this time, in terms of hundreds, we've got 35, 36, 37, 38. And we add that to the 50, because it's beyond 2.5, so that's 88. So we end up with 2.88 millimetres. The slide on the door latch is shown below. Name the turning process shown at A. Well, that's knurling. State an adjustment to the centre left that may be necessary before carrying out the process shown at A. Well, you have to knurl at a slow speed, so you might have to reduce the speed of the lathe. Name the turning process shown at B. That's taper turning. The slide on the door latch is made from aluminium. State two properties of aluminium that make it suitable for the slide. Well, first property would be that aluminium is an attractive metal, and another property might be the fact that it doesn't rust. It's got good resistance to corrosion. Describe two health and safety issues in the picture of a metal working bench, other than it being untidy. Right, so let's have a look. Right, we've got a bit of metal here and folder bars sitting overhanging the edge of the bench. They might fall off and hurt someone. We've got another bit of metal still in the vise, which could hurt someone walking by. We have a drill. They've still got a drill in the drill. It's not been removed. The chuck key looks like it's still in the chuck. We have a hacksaw blade just lying on the bench. We have a file where the handle has came off, just lying on the bench. Okay, so these are possible safety issues with this layout. The diagram below shows a metal shelving unit. So we've got bolts, spacers, brackets and the shelves themselves. The spacers are made from 12mm diameter round bar. The ends are drilled to accommodate the bolt. The tool shown below was used in this process. So just like when you have to centre punch a bit of metal and drill it on a pillar drill, on the lathe you have to use a centre tool to centre the metal before you drill it. So this is a centre tool. The shelves are made from sheet metal, drilled using a pillar or pedestal drill. Name the device that would be used to secure or hold the shelves for drilling. I imagine that would be an engineer's vice. Explain one reason why the shelves are shaped and drilled before bending. Well, you wouldn't be able to drill them if they're bent. Much easier to drill them when they're flat. The shelves are manufactured from mild steel. The mild steel becomes work hardened when shaped. It's annealed to make it soft and workable. Explain what is the term work hardened. Well, basically, if you're working with a metal, you're maybe filing it or rubbing it down or shaping it, it can become what's called work hardened, where the metal becomes really hard and brittle. So if you try to bend it, it might break. So you need to anneal it. So the next question asks you, what is the process of annealing? If you heat the metal up till it's red hot and then allow it to dry slowly, then that's what you do when you anneal mild steel, and you can then continue to use it. And a large view of the bracket and shelf is shown below. The bracket is also made from mild steel. Describe a suitable method of joining the brackets to the shelves other than using an adhesive or glue. Right, well you could have riveted these. You could use rivets, you could use screws, machine screws, it could be welded, it could be brazed, which is hard soldering technique. Any of these methods would be acceptable. The spacer is made from brass, which is a metal alloy. Describe what is meant by the term alloy. Well, alloy is where you combine two metals together to produce another metal which has better overall properties. State the property of brass which makes it suitable material for the spacer. Well, brass is a hard-wearing metal, which is probably a good idea to use it for the spacer. No, wait a minute, forget that. In this particular case, brass is an attractive metal. So you would use that for the spacer. State one possible finish that could be applied to the shelving unit. Well, you could spray paint it, you could paint it, you could lacquer it, you could plastic dip coat it, you could blue it. You can blue steel. State two reasons for applying a finish to the shelving unit. Well, it makes it look good and it protects it, stops it from rusting. Drawings of the shelving unit are shown below. Using the information from the drawings on page 18, complete the cutting list. So we've got the shelf, which we can see here, and we've got how many shelves? We need two shelves. The length is 120mm, its width is clearly 80mm, and it's 2mm thick. It's made from mild steel. The spacer is, well, this has got a spacer with the bolts attached at either end. So the actual spacer itself is 100, take away 10 and 10 for the two bolts, so that's 80mm. The bolts are 10, but then you've got the bit in the threaded bit, which is also 10, so there, and it tells you actually it's 20, so it's 20mm long, and how many bolts would you need in this? You would 2 per spacer, there's 4 spacers, so you need 8 bolts. Okay, thank you for listening. I hope this has helped you in doing this paper.